Welcome to today's video. In today's video, we will talk about this GPO Rock Shockwave module right here. Alright, so I have attempted to recreate this Grand Piece Online Rock Shockwave. Alright, and I've put it inside of a module script because that's the best thing you could possibly do when you want to work with shockwave effects. Alright, and I've just tried to recreate that one. So Arclight Studios has also recreated it, and mine differs a little bit from theirs. So from Arclight Studios, but also from the GPO one. So I've also put some of my ideas inside of it, let's say, even though they're not really my ideas, but I've just seen them somewhere. Okay. So you guys have probably seen how this looks like. Okay, so I'm not gonna showcase that. So what you guys will need is this module script, okay? So right click on the replicated storage and create a module script. So while we're using a module script, you might ask, so we could also put it inside of a local script, for example. So we have this local script inside of here, which is, which has the task to trigger this function, which at the end creates the shockwave. Now, when you would try to avoid using a module script, then you would need to take all of this code and paste it in each local script you want to use the shockwave in. Or yeah, you want to use the shockwave with. I'm sorry. All right, and as you guys know, those are plenty of lines right here. Okay, so we've probably got around 50 lines right here, and having an extra 50 lines in each local script just because you want to use that shockwave is not that smart. So we are going to use this module script and just put it inside of a function. Then all you got to do is that you have to call this function from each local script you want to use the shockwave with. Okay, so obligatory for each for each module script is to have this line and this bottom line right here. So local shockwave equals, and then those two curly brackets, and then down here return shockwave. All right. So they just automatically come when you insert a module script, and you won't have shockwave right here. You will probably have something like module, I think. I'm not sure. I'm not sure what the exact text is, but it is not shockwave, okay? Now right here, I've added two variables just to make things easier for you to edit. So as you guys know, this shockwave consists of rocks which just stick out of the ground, and then some kind of part upon those rocks. Okay, and the rock itself is always the same. So the rock color, as you can see, can be adjusted right here. The current color is gray. You can just put any color you want to in there. And we also have something called rock despawn time. So this is the time in seconds which it takes to make the rocks disappear after they have appeared. Okay, so changing both of these will of course result in changes for your shockwave system. Now right here we have this function, and this one is important. All right, it is important that you write function and then, very important, shockwave.create. Now let's say that you have something else besides shockwave up here. Let's say you have something like rock. Okay, so when you have something like rock up here, then you have to make sure that down here you also have to change it to rock, and here, very important as well, so where it is orangely underlined, you have to replace this with rock as well. Okay, so just for a case when you want to change that for whatever reason. So shockwave.create indicates that this create function belongs to this module. So if you require this module right here, okay, so module scripts have to be required like this. So require, and then you have to refer to this module script, which is in replicated storage GPO shockwave. Okay, so requiring this module leads to gaining access to this module, let's say, and you also gain access to everything which belongs to the module. So that can be functions, as right here, so shockwave.create, but also things like this. So just a quick lesson on module scripts. So you can make variables belong to module scripts like this, so shockwave dot and then the name of the variable, or functions. Okay, and by making them belong to this module, you're able to access them through local scripts which are not really part of this module script, but which have required it. As you can see, Q is basically the module script dot create, so I'm able to access this create function right here. Okay. Now, that's just a quick lesson on module scripts. Now let's really start on how this system works. Okay. So what we have right here is that we have a function, and this function requires one argument, which is called position. Now, it is important that this position is in a C frame. Yeah. So this might be a little bit misleading because I've called this pos, so stands for position, but this has to be in C frame. That's very important, guys. If it is not in C frame, then you cannot really work with it. But we'll get to this and to this local scripts on how you trigger this rock shockwave system soon. Okay, so position in C frame. Now down here, we are creating a folder inside of the workspace, and we call this folder rocks shockwave. And right here, we are already telling that we want to put this rocks instance, so this folder, inside of the debris after rock despawn time, so 5 seconds plus 2 seconds, so 7. So after 7 seconds, we are going to get rid of this whole folder. And you might ask, alright, so what is the purpose of this folder? And as the name already suggests, this folder will contain all of the rocks, so all of the instances, all of that shockwave instance is going to be put inside of that folder. Now right here, we have a loop of 30 times, alright? So we loop through 30 times, and each time we are creating a part inside of that folder. We are making sure that it is anchored and can collide as false, and we give it a random size, alright? And the height is always the same, so that's important. Right here, we have already declared two variables. Upper part color, so upper part material and upper part color. As you know, our shockwave consists of a rock and then of an upper part, which is upon that rock, okay? And we want that upper part to adjust to the ground it has came from. So let's say that you try to trigger the shockwave module on sand. Then the rock itself will stay a rock, but the part above is going to be sand, okay? And in order to really be able to do that, we have already two variables, which are by default. So the color is by default really black, and the material is already smooth plastic by default, okay? But we are of course going to change that, according to what the actual ground is. So whether the ground is sand, then the upper part color becomes the same color as that sand, and the upper part material also becomes sand, So this highlighted code right here is basically where this happens. And just for the case that we are not able to really define what kind of ground this rock is growing upon on, we still have those default settings, okay? And that's literally the meaning of those. So we have them as default settings. So if we would leave these empty, and if these checks down there fail, then we wouldn't even have any information right here. We can apply to this upper part down here after, and this will lead to errors, alright? So just to give you a quick outlook on why this is important. Now, right here, we will now take a look on how we can actually tell what kind of ground this is. So what kind of ground our rock shockwaves are coming out from. So we are working with raycasting, okay? You guys may know it. So if you guys don't know what a ray is, you can imagine a ray as some kind of line, alright? So, and this line, it is pretty thin. So, it is thin and it is not visible to you. So that's the most important thing. And it always has a starting point. Wait, now I'm unable to see it as well. It is somewhere here. Come on, man. Yeah. Imagine that this one is invisible to you, alright? But just to demonstrate this to you. So ray has a starting point. Let's say that the starting point is right here, okay? And it has an ending point, which is right here now, okay? So just for just to explain this to you. So starting point here, ending point there, and anything which intersects with it or which touches it, which crosses it, call it however you want to call it, is going to be trigger that ray. All right. So we know when a part, for example, moves through this ray like this, or when we have a dummy right here. Come on, which moves through like this as well, all right? So we can surely tell when this happens. And when this happens, we, just are able to refer to that part which has done that and so on. Now, the idea is that when we create a part, which we are right here, all right? So we have created this part, and when a part, for example, is somewhere around the character, then we will spawn an array above that part, which is going to face down. So it has its starting point up there somewhere, and the ending point somewhere down here, okay? And obviously, when this happens, it will only cross this one, so this part right here, or this part, depends on where the part itself is spawning, but it will cross the ground, and that's the way on how we are able to tell what kind of ground this rock is on, okay? Now you might ask, alright, so if the starting point is up here, and if the ending point is somewhere down here, then we not only have this ground in between, but also the rock itself. So how is this ray able to tell apart the rock and the actual ground we are looking for? Now, good question, and that's the reason why we need a third thing, which is ray settings or raycast params, so raycast parameters. And that's happening right here. So ray settings equals raycast params.new. You can consider this as some kind of template for ray settings, and the ray settings are settings like the filter type and filter descendant instances. So basically everything regarding the filter. And now to get back to your question, how is the script able to tell apart this rock and the ground? We are of course adding the rock and every other rock which is going to spawn into that filter list, so that the ray completely ignores the rock and only has eyes for, this ground right here. Alright, so that's how this happens. So ray settings filter type is going to be set to blacklist, so everything which is inside of that list is then going to be ignored. And ray settings filter descendant instances, so this one is asking for the instances or the descendants you want to filter out. And rocks refers to the rocks folder, and it is going to filter out every descendant of it. So everything which is inside of that folder is then going to be blacklisted, okay? And right here we are actually creating that array. So you create it by typing in workspace raycast. So workspace, of course, is this one, and then this colon raycast creates that array, so casts that array to be exact. And right here, so this is interesting to see. This is actually the way on how you align those rocks in a circle. All right, so this was actually something I struggled with, but it is actually pretty easy. But I'm going to be explaining this soon. All right, so just know that this one is the starting point, and this comma right here separates this first argument, which is the starting point, with the second one, which is the ending point. And the second comma, it separates the second argument, aka ending point, with the third argument, which is ray settings. Now I'm going to be explaining this starting point and ending point, and especially those C-frames inside of there soon, once we get to this part down here. But just to continue, so if ray means if something has crossed the ray, and we should even be more precise. So if something has crossed the ray or has touched the ray, call it however you want to, and that something is, now we should really do it like this. So if ray instance, so that's basically this instance which has touched, crossed, whatsoever has done to the ray. So if that instance is a part, or ray instance is a union operation, or ray instance is a mesh part, then so those are the three parts which are able to work. So if you have anything besides those three types of parts, then you cannot really do this, okay? But I highly doubt that you're able to build a map by having some other parts as well. So you might have a truss part, a wedge part, so some things like these. Wait, corner wedge, yeah. So we could possibly also add where is it? Ray instance is a wedge part. I'm not even sure if this exists, but it used to back then. Yeah, so you might have other part types such as truss part, but nobody uses them like for real, so I don't see the point in that, to be honest. But yeah, so if your instance falls into either one of those types, so part, union operation, mesh part, wedge part, then we wanna override our default upper part colors and materials with that instance's brick color and materials, as I've already explained it to you. Alright, down here we are creating this upper part I was always talking about. And this upper part is going to be put inside of the folder. The material is going to be that upper part's material, and the color also the upper part's color. Can collide is going to be set to false, and the size is going to adapt to our rocks part size. So x size x. So basically the x-axis becomes the size of our rock part's x-axis, while the height stays at 0.5. All right, so pretty thin in relation, of course. And the z-axis also adapts to our rock part's z-axis size. Now right here, we are setting the C-frame of our upper part to our rock part C-frame. And down here we are welding this upper part to our rock part. So weld, which is inside of the upper part. Part 0 is the part you always weld something onto. In this case, we are welding the upper part to the rock part. So X is our upper part, not our rock part, I'm sorry. And that's also the part we are trying to weld the upper part onto. While part 1 is the upper part, as I've already told you. And C1 is the C-frame we want to apply onto that weld. And this C-frame makes the upper part move up, as the name suggests, alright? Now, down here, so this is very important to understand, because this is where the magic happens. So this is where the parts are aligned in a circle around our player, okay? So you have to really be able to imagine this, okay? And I'll really try to break this up. So pause is the C-frame which is given, and which is our origin pause, our origin position. So everything, or the shockwave, is going to revolve around that position, okay? That's important to know. Now, since this is a loop, we can also work with factors such as I, okay? That's also important to know. Now, we take the origin position, or the origin C-frame, let's say, and we multiply it with a C-frame, which makes it move down. We could really ignore this for the moment, because this will only make things complicated, alright? So try to ignore this. Just know that this C-frame moves it down for the sake of moving it back up later, so right here, because of the fancy look, alright? But just ignore this for the moment. More important is this one, okay? So this one is very important. So before moving from our origin position, to any other position on the x-axis, we have to rotate it, okay? And rotating this is very important, because by rotating it and then applying some numbers on the x-axis, you really create that effect of moving in a circle, okay? So I really would like to show this to you. I might even show this to you. Let me just quickly, let me just quickly do something for you right here, okay? Because I really want you guys to understand this, because I was really struggling with this until I found out how this works. So, and really appreciate this, because not every YouTuber takes his or her time to, you know, really explain this to you, and you barely find something, or you don't even find something. So my first impulse after, you know, not knowing what to do was to Google this problem, and I wasn't able to find something interesting. Most of the stuff was complicated and wasn't even related to my problem, and I didn't want to ask on a dev forum as well, because I'm not even logged in, to be honest. I barely use the dev forum. And yeah, so I've tried to figure out how to fix this, and I was able to do so. No, and you're able to do as well. So we're now creating a part. All right, so Now it is time to create this angular, no, not this circle alignment. So X C-frame. So this part C-frame is going to be, now we need the base, alright? So we're not able to use this position, so I'm going to use game, players, local play, and I know that I'm not able to refer to the local play inside of that module script. I'm just going to take this and post it inside of our, this executed down here later on, but I just want to finish this, alright? So we take our humanoid root part C-frame as the base, okay? Now, we want to rotate, alright? That's important. We want to rotate. So if you imagine a part when it spawns and when it is put to our humanoid root part C-frame, I forgot to write out humanoid root part. So when we put the part to where our humanoid root part is and rotate it, we actually adjust the direction it is then going to move into, okay? So I hope that this is clear to you. By rotating this, you actually adjust the direction. Now, we only want to rotate the Z-axis because that's the only axis which really makes a huge difference in direction. And now it is important, in order to be able to create this circle rotation, we have to do some math, alright? So what you want to do is that you want to take 360 degrees and you want to divide this by the amount of loops you have right here. So the total amount of loops, which is 30, and then you get 12 as a result, okay? And you're going to take your result. So it might be that you want to increase this amount, depends on you. So you take that amount, and then, as I've done right here, you do your result multiplied with the loop. All right. And then you have a part, or you have parts which are aligned in a circle, okay? And now we want to multiply this with one more C-frame. I'm sorry, so you do not really have that circle alignment yet. You only have a bunch of parts which are rotated and which form a circle because they're like in each other, but they're not really moved out yet. So if you want to move them out, you want to apply some numbers on the x-axis. So the lower the number, the nearer they are to your character. The higher the number, the more far away they are. Okay, just so you guys know. And now we can take this and post it down here. And then we can play this, and then I can show you that this works, okay? So I really wanted to explain this in detail because, as I've told you, I was struggling with that, and I hope that this is now clear to you. As you can see, this is how it works, okay? We have 30 parts right here, aligned in a circle, and you guys were even able to see how the parts were created. Look. I find this so fascinating, really. And this is how it works, alright? So, the parts spawn, they are put to our humanoid root part C-frame, and then they receive their rotation, and then they move from that rotation on 20 into one certain direction. And this happens with each part, and the result at the end is the circle, this circle alignment we receive and we want to have, okay? And this is what happens right here as well. So we have this rotation right here, and then we have this, this C-frame applied right here, which moves the part 15 studs away from our character. Okay, and down here we have one more C-frame adjustment, and this one just rotates the rock. So just rotates it randomly once again, just to have some more messier look. So just to really really make this look like some kind of shockwave and not that organized, because as you guys have seen the parts earlier, they were pretty organized and they wouldn't really fit into the image of a shockwave. But having some randomized rotation after you have adjusted all of the position, so having this randomized rotation then really makes it look like a shockwave, in my opinion. And right here we also apply the color to this rock, so rock color, and we apply the material rock to that rock as well. And right here, we have a tween service, or a tween, let's say. Yeah, we have a tween. And what happens right here is that, maybe I should first of all explain how this tween works, alright, or how tweens work in general. So let me just briefly explain it. So when you have an instance, for example, let's say you have this part, okay, and you have this properties tab, okay, so on the right hand side right here. I don't know if you guys are able to see it because I edit my videos a little bit weird, but I'm not really, I don't really know if you're able to see this, but if you do, then you see this transparency property right here, so this attribute right here, right? It is currently at 0, and if you want to change this to 1, means to invisible via script, you can either go from 0 to 1 directly, like this, but there is no transition in between, okay, and that's a problem. Or you could go slowly, so from 0 to 0.2, 0.4, 0.6, 0.8, and 1, and then you would have some kind of transition, not the best transition you could possibly do, but some kind of transition, all right? And what this tween service now does is that it creates the best transition you could possibly create via script, okay? So this is what this tween service does. And we now want to create a transition for our rock shockwave. And rock shockwave in this context also means the rock itself, but also the upper part. And we want to move our rock shockwave from its current position, aka -20, so in the ground, to, where is it? -5 means up, so above the ground, okay? And we now want to create a transition in between the state where the rock is inside of the ground to when the rock is above, so up on the ground. And this is what happens right here, okay? So tween info are the settings we tween with. So this tween happens in 1 second. The easing stars linear, the easing direction is out, and this third argument, so those curly brackets, they describe the goal state of attribute when achieved, alright? So C-frame equals position. So basically everything we had up here, just with the only difference of, up here, just with the only difference of -5 instead of -20, and this makes the rock move up and stick out of the ground, okay? And once, not yet. Now, we have a coroutine right here. So coroutine.resume, coroutine.create, right? What happens in between those two lines, because of this coroutine, is that this runs apart from the rest. So this will not interrupt any further progress of the script, okay? Because usually when you add a wait, it delays and it pauses the whole script until that wait is over. But this does not happen because we have now put this inside of a coroutine. So maybe to understand this better, you can imagine that those lines run in the background now, as a program on your computer does. Okay. Now wait rock despawn time. So this is our despawn time, so 5 seconds. So after 5 seconds, we want to create another tween, which then makes the rock move back into its default position, so -20. All right, and once this tween is done, so you have to play the tween. By the way, I didn't explain that, but you have to play it after creating it. So after this tween is done, so completed, we want to destroy X and X2. So rock part and upper part. Okay, and that's it. That's how this works. Okay, and now if you want to trigger this, so I have this local script right here already set up. So I for now trigger this via pressing the Q key. So I have this user input service, and when an input begins, I receive the input and GPE. So I've already explained all of this stuff on my channel. So if the input is the Q key, then I do. Alright, so this might be a little bit misleading because I've called this Q as well, but let me call it module then. So all you gotta do is that you have to require this module script, as I've already explained it to you, and then you do module.create, and that's when how you access that create function inside of that module script. And then you want to input the C frame of the position you want to create the shockwave onto, alright? So the position where the shockwave should revolve onto. And this one right now is the humanoid root part C-frame of our local player, but this could also be the humanoid root parts C-frame of your target or any other random ass position. You just have to make sure that you have the C-frame of that position, alright? And that's it, guys. So thanks for watching. Leave a like, subscribe, share this video to all of your friends, leave feedback in the comment section, guys. Take care and see ya.